Hello everyone! Today I will be discussing what are factor theorem. The factor theorem is a theorem linking factors and zeros of a polynomial. It is also a special case of the polynomial remainder theorem. The factor theorem states that if p times a is equals to 0, then x minus a is a factor of the polynomial px. And conversely, if x minus a is a factor of p times a equals 0. Here is an example. Show that x minus 4 is a factor of 2x cubed minus 6x squared minus 5x minus 12. Here you can use the remainder theorem. P times 4 equals 2 times 4 raised to cube minus 6 times 4 squared minus 5 times 4 equals to 12. The answer is 128 minus 96 minus 20 minus 12 minus 12 is equals to 0. Therefore, x minus 4 is a factor of 2x cubed minus 6x squared minus 5x minus 12. When it comes to the factor theorem, you can also use the synthetic division. For example, x minus 4, prove that x minus 4 is a factor of 2x cubed minus 6x squared minus 5x minus 12. Here is the synthetic division. Multiplied by 4, bring down 2, negative x, negative 4, then negative 5, then negative 12. Since the 4 is negative, we turn the 4 into positive. Bring down 2. 2 times 4 is equals to 8. Negative 6 plus 8 is equals to 2. 2 times 4 is equals to 8. Negative 5 plus 8 is equals to 3. 3 times 4 is equals to 12. And the negative 12 plus 12 is equals to 0. Therefore, x negative 4 is a factor of 2x cubed minus 6x squared minus 5x minus 12. And that is how you do the factor theorem. And that will be all, everyone. I hope that you all understand the factor theorem. Bye-bye!
Synetic division. Synetic division is the simplest and shortest way of dividing polynomials by linear expressions of the form x minus a. In this method, only essential parts of the long division are written. Example: x squared minus x minus 10 by x minus 2. Solution is: arrange the terms of the polynomial in descending order of the powers, then write horizontally the coefficient of each term. Replace every missing term with 0. The terms of the given polynomial are already arranged in descending order of power, so the coefficients can now be written horizontally as follows: 1, negative 1, negative 10. Step 2. Write the value of a on the left of the first numerical coefficient, then put a combination of a vertical and the horizontal bar to separate a form the coefficients. In this example, x minus a equals to x minus 2. Thus a equals to 2. 2, 1, negative 1, negative 10. Step 3. Draw a horizontal bar, one space below the coefficients, and then bring down the first coefficients. Step 4. Multiply the first coefficient by a equals to 2. And then write the product below the next coefficient. 2 times 1 equals to 2. Step 5. Add the result in step 4 and the second coefficient. Then write the sum below the horizontal bar. Negative 1 minus 2 equals to 1. Then, repeat step 4 and step 5 until there are no coefficients left. 2 times 1 equals to 2. Negative 10 minus 2 equals to negative 8. Finally, take all the numbers in the last row except the last one as the coefficient of a term in the quotient. The quotient must have degree of less than that of one dividend. The dividend example is a quadratic expression degree 2. So the quotient must be a linear expression degree 1 written as 1x plus 1 or x plus 1 and negative 8 serves as the remainder. The final answer could be also written as x minus 1 minus negative 8 over x minus 2 or x plus 1 minus 8 over x minus 2. That's all. Thank you. So that's how you use synetic division.
So for today, let's talk about the remainder theorem. Let's know what the remainder theorem is or states and know its function. So what the remainder theorem states is that if f of x is divided by x minus k, which would be a factor, then the remainder is r is equal to f of k. So what this means is that let's try dividing this into this. So to use synthetic division, negative 4. I'll do 3, 8, and negative 20. There. So if I divide this into it, I'll get drop 3 times 2, negative 12, negative 4, 4 times 4, 16, negative 4. So my resulting factor would be 3x negative 4, right? So, but you would notice our remainder is negative 4. So what the remainder theorem tells us is that I can also determine that this x plus 4 is a factor of this by evaluating negative 4. So what I can do is that I could say, wait, erase ko lang. So what I can do is that I could say f of k, wait, erase ko lang ni. I could say f of k is equal, k in this case is negative 4, so negative 4, then is equal to 3 negative 4 squared plus 8 plus 8 negative 4 negative 20. There. So the same thing if you take your factor, divide it by this, and you get the remainder of negative 4. If I evaluate for that same negative 4, I'm still gonna get negative 4 in the remainder theorem. Let's take a look. Equals 3 times negative 4 times negative 4 equals 16. 3 times 16, 16, 10, 30, 48, 48 plus 8 times negative 4, 8, 42, negative 32. Wait, that's ko lang na. Tapos, negative 32 minus 20. So, 48 minus 32, 30, bale 6 minus 20, is equal to negative 4.